The first four are pretty basic. The last two are the more difficult ones. So this piece right here that you're actually solving for initially is x minus 36. You can set up a completely different variable here. So you can say, okay, I'm going to solve for y, which is this piece right here. And you could say 48 equals the square root of 36y. When you do that, you're going to get 64. But keep in mind you solved for that piece, not what it was asking for. And you need to add those together to get it. So if the piece that you need to finally solve for is not the one that you'll initially get with what we have learned, you can just create a new variable. So you could create a variable here for this piece of it, right? And then you could say 12 equals the square root of 16y. And again, when you solve for that, you're going to get that y equals 9, but you did not answer the question yet. You just got this piece of it, and you need to add these two together to get your 25. All right, proportional parts. We have done specifically right triangles up to this point when we're talking about proportional parts. Now we're going to talk about really any triangle. All right, a segment parallel to one side of the triangle that intersects the other two sides divides those sides into proportional parts. So if you have any line segment within your triangle that is parallel to the other side of that triangle, this line right here is parallel to a side of the triangle. It splits it up into proportional parts. It's unlike the median. So the median of the triangle actually hit it at the midpoint, right? So when we did mid-segment, it hit at the median and the median. This is different. This does not make these equal. It actually makes them proportional. And so you'll see that AD, if we put AD over DB, that is proportional to AE, which is right here, over EC. So it creates proportional parts that they're going to be in the same proportion where they break up the sides of this. If you look right below it, you'll see that you can set these proportion up a number of ways. So this first one right here, this proportion right here, they did V to X, so the little piece to the little piece, compared to the whole side, U, the whole side here, to Z. So the whole side to the whole side. So you can see that proportion. If you look at the next one, this one right here, you'll see that they compared V and W, which is the piece and the piece that we just talked about. So V, I keep using that instead of so V to W, and they compared that with X to Y, which is the one we just did. All right, that's a proportion. The next one they did, if you look at the next one here, right there, they have V to X, right? V to X. And they compared that to W to Y. So they just changed out how the proportions were written. They have V over X, W over Y. If you look at the next one, W to U, so we have this guy right here. W compared to the whole side here, U. And then Y to the whole side, Z. So there's a ton of proportions that can be set up with these. Let me delete that piece. Ton of proportions that you can do. This last one, W to Y. So those two compared to U and Z. So a lot of different ways to find proportions in here. A lot of different ways to find proportions depending on what you have and what you're looking for. All right, so look at this first example, example 1. They want us to find EC. Now here's the deal with these proportions. know what you're looking for. It's very important that you know what you're looking for. Just like on your quiz, some of you solved for a piece of it, validly solved for a piece of the triangle, but you did not answer the question. All right, so when you have this and it says find EC, make sure you know what piece of that triangle you're looking for. All right, make sure you know. And then decide what type of proportion you're going to set up. They set it up with 7.2 over the 4.8. And if we did that, then this piece that corresponds to it needs to be on top here, 10.8 over the EC, which is what we're looking for. And instead of writing EC, you can write a variable. So just like on the when I just gave you that example, you can write a variable there wherever you figure out you're going to do it. And that way in your equation, you have a variable. And then you're just going to do cross multiplication like you would. 7.2 times x equals 4.8 times 10.8. And you're going to multiply and then divide. You will see that EC equals 7.2 meters. I will say too that when they give you units, you need to make sure they're all the same units as well. Like this is something, especially on a standardized test, make sure that these are all in the same unit as well. Just to double check. All right. Let's look at the next theorem here, the converse of this theorem. As if a segment within a triangle divides it into proportional parts, then you know it's parallel. This is just the converse. So the first way that they gave it to it, they don't have parallel marks. What they're saying is if you can prove that the two pieces are proportional, then you can assume that they are parallel. So in this case, they would say, hey, are those lines parallel? And the way you prove that they're parallel is you prove that they're proportional parts, all right? And so if you look at that example 2 there, determine whether or not XY is parallel to WZ. So they want to say, is this parallel to this? If it is, then it should have broken these pieces up into proportional parts. And so you're just going to set it up and say, does it work? So if it works, then we could put 6, it's bouncing around on me. We can put 6 over 9 and then see if that equals 10 over 15. So we can say 6 over 9. Does that equal this piece that corresponds 10 over 15? How do you know if they're proportional? You can do cross multiplication if you want to, and they should equal the same number, or you can reduce your fractions and they should be the same fraction. All right, both of those will work. So if I reduce this, what goes into both of those? What goes into 6 and into 9? 3. So we have 2/3. What goes into 10 and to 15? We have 2/3. The other way to do that is cross multiplication. 6 times 15 should equal 9 times 10. If that's true, either one of those, if you can reduce them to the same fraction, or if you can prove that the cross multiplication is true, then you can say yes. These are parallel lines. So it's just the converse. They're asking the same question in a different way is what they're doing. One way you're finding the piece, assuming they're proportional. One way you're saying they are proportional to prove that they're parallel. All right. So remember what transversal means. Transversal crosses more than one line. So both of these are transversals. You can see that they have told us that these are parallel lines based on that. So all 3 of those are parallel. And so what it's telling us is it has broken those into proportional parts. So these should be equivalent proportions here. Those should be equivalent proportions is what it's telling us. The distance from Malvina Avenue to Moody Avenue is 335 feet long along 83rd Street. So the distance from one to the other. So from Malvina to Moody is 335. So they have given us this right here. It says, and 440 feet along State Road. So 440 feet along State Road. They want to know, so this piece right here is 440. Find the distance from Moody Avenue to Austin along State Road if the distance is 1,005 feet along 83rd. Okay, so they want to know the distance along this road if this piece is 1,005. And so what you have to look at is that you have these transversals here, all right? And they are broken up by parallel lines. So we have these transversals, and then we have parallel lines. 3 parallel lines right there. And so we have proportional parts, as long as those are parallel. We are looking for this piece right there. So they actually set it up with these two. They set it up with this is the numerator and this is the denominator, x over 440. And if this is the numerator here, then they set this up as the numerator, 1005, over the denominator that corresponds there, 335. And then they just did cross multiplication. So 335x equals 440 times 1005. And they solve for that 1,320 feet. So that tells us how far Moody is from Austin along this road here, which makes sense. It would be bigger than this because of the angle, right? And so we found the distance between the two streets. So that if they have t over u, it would be w over x. So if they put t in the numerator, u in the denominator, w in the numerator would correspond to x in the denominator. For b, they have v to t, and then w in the denominator. So t was in the denominator, w in the denominator, v in the numerator means that y would be in the numerator. For c, we have x in the numerator and u in the numerator, and then they have v in the denominator under u, so that means that y would be in the denominator under x. And then for this, they have w in the numerator and t in the numerator, and then they have x plus y in the denominator, so that would be u plus v in the denominator. You could have done this a multitude of ways, but 2 over 3 should equal x over 6, which gives you 4. When you do your cross multiplication. This is your angle bisector theorem. The bisector of an angle in a triangle divides the opposite sides into segments that are proportional to their adjacent side lengths. So we have this angle bisector here. You can see that it didn't divide these evenly, right? That's obvious. What it's telling you is it divided it proportionally. So if you compare the side BD to the side DC, that is proportional to the side AB compared to AC. That's what it's telling you. So that is the proportional division there. So look at the example. If CD is the bisector of ACB, find X and Y. Find X and Y. So first of all, they've given us a little bit of extra information. What kind of triangle do we have here? What kind of triangle is this large triangle? It's a right triangle. Does that help us in any way? There's a theorem that's going to help us find this guy. What's the theorem? Pythagorean theorem. So what is this? A squared plus b squared equals c squared. It's actually a Pythagorean triple. It gives us 5, right? So if I wanted to find this entire section here, I can say that entire section, we'll call it C, should equal these two, right? Which gives us 25, so C is going to be 5. So we have this piece right here, C is 5. All right? So if I'm looking at proportions then, there's a couple ways I can do this. Just like I did here, if I have 3 over 4, so that's my first proportion like we did here. We did these two sides over each other. So 3 over 4 should equal this piece over this piece. All right, so x over y. But I have 2 variables here. I don't want 2 variables because I'm not going to be able to solve. So I need to write one of these in terms of the other. So if this is x, and I know this is 5, this piece should be 5 minus x. Everybody agree? Y should be 5 minus x. So I'm going to replace this guy with 5 minus x. X over 5 minus x. And then I'm just going to do my cross multiplication here. Another thing I saw on the quiz, when you cross multiplied here, you didn't put parentheses and distribute, okay? So anytime you have a group, you have to keep it as a group. So here I am going to have to distribute this guy. I'm going to say 15 minus 3x equals 4x, right? Add that over, 15 equals 7x, so x equals 15 over 7. All right, 15 over 7. So I have my first piece, x equals, you can write it, I think they wrote it as a mixed number, 1 2/7. And then y is just going to be 5 minus that. So it's just going to be 2 6/7 when I subtract that from 5. So if they wanted x and y here, we could solve using the entire hypotenuse. All right, let's go over this one. There are a couple ways you could have set this up. So if you did this as the numerator, 2x minus 4, and this is the denominator. So let's say you set your proportion up that way. Then the corresponding piece should have been 12 corresponding in the numerator position and 20 in the denominator position. All right? Again, you could have set that up a couple ways. You could have had numerator, denominator, then numerator, denominator. But you need to make sure that however your first one is set up, your second one tracks with it. All right. The other thing I would say that might make it a little easier is to reduce. So this one right here cannot reduce. So we're going to leave that as 2x minus 4 over 15. This one right here can reduce. What goes into 12 and into 20? 4, right? So this can reduce to 3 over 5. When you do that, you make your numbers smaller, less room for error, right? Versus huge numbers. And then you can just do cross multiplication. Again, I have a group here, so make sure that you multiply it as a group. Second problem I saw in the quiz was not distributing. All right, so I'm going to multiply the 5 across, so 5 times that group. And then I'm going to multiply the 3 across, the 3 times the 15. All right, again, make sure you distribute. So 5 times the 2x minus 5 times the 4 equals 3 times the 15. All right. And hopefully they gave us a decimal here. All right. So then we're going to add my 20 over. And then divide by your 10. All right. So in this case, we were supposed to solve for x. If they had asked for a side length or something like that, make sure you just answered the question. All right, so in this case, they were asking for x, but if they're asking for like a specific side length and you have to plug it back in, just pay attention to make sure you've answered the question. All right, I want to try a couple more of these that are a little more difficult, and then we'll be done. So go ahead and try those two. So the first one, they gave you several pieces. They said A to D is 8, A to C is 12, D to B is X, B to C is X plus 2. So I put X over 8, my numerator over denominator, which means this is my numerator, this is my denominator. Cross multiplying, X times 12 is 12X, 8 times the group. Distribute, 8X plus 16, subtract your 8. X equals 4, which is great, but that's not what they asked for. Okay? So X equals 4 is getting to my answer, but I'm not done. They specifically ask us to find AB, which is this entire length here. I found X equals 4. So to find the entire length, I needed to add 8 plus 4, which is where I got my 12. All right, let's look at the next one. I put my numerator as 5X and my denominator is X plus 2, which means my numerator here was 15, my denominator was 3X. I did reduce this, okay, by 3. So I have 5X over X plus 2 equals 5 over X. 5X times X is 5X squared. And then I have 5 times the group, which I distributed. So I have 5X squared equals 5X plus 10. This is pulling back from algebra 1. If you have an X squared, you need to set it equal to 0 and then factor and solve. So I moved my 5X over. I moved my 10 over. So I have 5X squared minus 5X minus 10 all on one side and 0 on the other. This pulls back from factoring or unfoiling from algebra 1. I noticed there was a 5 in common, so I divided that out of everything. I divided every single piece by 5. I have X squared minus X minus 2. I'm looking for factors of 2 that subtract to give me 1. That's 2 and 1, specifically a negative 2 and a positive 1. They multiply to give me negative 2. They add to give me negative 1. That is factoring from algebra 1. So then I set each piece. X minus 2 equals 0. That gave me positive 2. X plus 1 gives me 0. That gave me negative 1. Why did I not take the negative 1 as my answer? Why can X not be negative 1? These are the two. Yeah, I'm looking for a length of a triangle. If I plug a negative 1 in here, I would get negative 3 as the length of this side. I would get negative 5 as the length of this side. That cannot work. So automatically here, my negative was excluded. My only option then was 2. All right, and you can check it. You can plug a 2 in. Does 6 over 15 equal 4 over 10? Does it work? And you would see that the proportions are correct.